Hi everyone, welcome back to my channel. Now in this video, we'll solve the following initial value problem dn dt plus 1 by t times n is equal to t with the initial condition n of 2 is equal to 8. So note that this is a first order linear ODE. Now we know the first order linear ODE has the following form dn dt plus p of t times n is equal to q of t. Now by comparing, we get p of t is nothing but 1 by t. Now we know the formula of integrating factor for the first order linear differential equation, which is given by e to the power integral pt dt. Now what is pt? It is nothing but 1 by t. So by doing the integration, we get e power ln t. So e power ln t is nothing but t. So now multiplying by integrating factor t to the both side of 1, the given equation, we get ddt of n times t is nothing but t into t, which is nothing but t square. So nt is equal to integral t square dt. Now integral t square dt is nothing but t cube by 3 plus c. Now note that it is given that n of 2 is equal to 8. So n is 8, t is 2. So we have 8 times 2 is equal to 2 cube by 3 plus c. So c is nothing but 16 minus 8 by 3, which is nothing but 43 by 3. So we have the required solution. Nt is equal to t cube by 3 plus 43 by 3.